Hello, we are here for another session of Decision Science for Operations Management. We are going to cover another case in simulation in Chapter 12. In this session, we will do Case 5. That is a little bit different from all the 4 simulation cases we discussed together so far, because as we have always said, simulation could be learned in the best way through practice. So always when we do new cases, it contributes better to the goal of learning simulation because we are tackling different types of simulation, different types of cases. We are not just focusing on one type of simulations models and do examples and cases like that. Okay, let's read the case together and do the simulation model together. Okay, the wedding date for a couple is quickly approaching, and the wedding planner must provide the caterer an estimate of how many people will attend the reception so that the appropriate quantity of food is prepared for the buffet. Of course, from reading these 2 lines, we notice that again there is a bold and a strong presence of uncertainty in this problem. And when it is uncertainty, of course, one of the ways to tackle the challenge for decision making is simulation. The following table contains information on the number of RSVP guests for the 145 invitations. Unfortunately, the number of guests doesn't always correspond to the number of RSVP guests. Here we see the table that in the previous slide it was talking about. It says that we have 145 invitations, and here we have 50, 25, 60, 100. When we sum up these numbers, it is 145. But what does it mean? That it means RSVP guest 0, number of invitation 50. Now now we have it. Okay, here is the table that we have, and as we noticed in the previous one, it says the total number of invitations are 140 is 145. Why I cannot write? Okay, 145 is the total number of invitations. Out of this 145 invitation, 50 invitations have said they will not attend. So as you see, RSVP guests is here. It says it is 0, they will not attend. And how many of that 145 invitation has announced that? 51 of them. Okay, Another one, it says number of invitation. 25 of the invitation has announced that they will come alone. They will come solo. So we have these. 60 of the invitation has been responded and they said they will come with a companion. And 10 out of 145 invitation didn't respond. So no response. So it means that out of 145 invitation, 135 people or 135 invitations are replied. 50 of them have announced they would not participate. 25 of them announce only they will come alone, solo, and 60 of them have announced they will come with a companion. So if we consider that everything is for sure, we can say what is the number of guests. Here we have 1 times 25 plus 2 times 60. So here we have 20 and here we have 120, and so totally we come up with 145, because here we have 120 and here we have 25. Okay, so what about the no response? If we assume that none of them will come because they didn't respond, so the total number of guests who are coming would be 145. But someone may say, no, it is not that. Some of the no response people may come. Probability, uncertainty. They may say, even those people who have announced they will attend with their companion may come alone, or even they may not attend. With the people with the invitation that RSVP'd as coming solo, they may come with a companion, they may come alone, or even they may not come. So all these uncertainties make planning a little bit more challenging, and it has happened to all of us that we invited some people and they RSVP'd as coming, but they didn't come, or they changed the number of companions, or even we have been invited and something happened that we couldn't go according to what we have planned. I'm not saying that it has happened to all, but I'm talking, for example, about myself, and usually it's something that at least we have seen it, most probably. So the problem that we are tackling, I'm telling you that the things that, for example, I'm telling about myself that, yeah, I have seen something that happened to me, or I have witnessed it as the invitee or inviter. So I want to tell you, this case that now we are doing is a very common case. It is not a fictional case. It is not an imaginary case. It is a very practical and a usual case that we are going to do together today. Okay, so in the second paragraph, if we go and start reading it here, based on her experience, the wedding planner knows it is extremely rare for guests to attend a wedding if they notify that they will not be attending. So it is talking about 0 RSVP guests. It says that there is certainty over there, and it is about our case. So if they have said we are not attending the wedding, they for sure will not attend. So we can be certain regarding that invitation, and says, okay, 50 of the invitation would have 0 guests. Therefore, the wedding planner will assume that no one from these 50 invitations will attend. The wedding planner estimates that each of the 25 guests planning to come solo has a 75% chance of attending alone. So it says, although they say they have RSVP themselves as solo attendees, but there is only 75% chance of they come to the wedding according to what they have RSVP'd. So 75% they are gonna do it according to their announcement, but there is a 20% chance of they not attending, and also a 5% chance of bringing a companion. So if I want to give you the heads up, if I want to give you the hint, I should tell you that now we have discrete probability distribution. 3 probabilities of not attending, attending solo, attending with a companion. So we have 3 probabilities, and the probabilities of not attending is 20%, attending solo is 75%, and attending with a companion is 5%. So you need to create that numbers. I guess now you have a good understanding of the simulation model you are supposed to make. For each of the 60 RSVPs who plan to bring a companion, there is a 90% chance that she or he will attend with a companion, 5% chance of attending solo, and a 5% chance of not attending at all. For the remaining 10 people who have not responded to the RSVP, the wedding planner assumes that there is an 80% chance that each will not attend, a 15% each will attend alone, and 5% chance each will attend with a companion. So now we have this information, this case description, as well as this table to do our simulation model. Now it is the time for doing activities. Activity 1, it says set up the raw empty spreadsheet simulation model. It means that here it is asking you just to create the structure of the simulation model you have. For example, what are the most important features, or if you have any column for the generating a random number, just here it asks you to figure out about the random numbers that you need to generate, the columns that you have, exactly similar to the things that we have discussed so far. So you just create this structure, and after that you try to populate it. Of course, for example, one part is about the number of simulation. What it is the things that we want to simulate? We are going to simulate this event in terms of the number of attendees for 1,000 times, and we will calculate the average and to see what is the number of the guests that we should expect in this problem. So please, my friends, take your time and make sure you are making a thorough simulation model. And again, there is no need for populating it, so you just create an empty structure exactly with that yellow columns and gray columns, and after that, when you are done with this, you start populating it to get the results. As we have talked about it in the previous cases that we have done, to be able to do the best structure, you should have a very good understanding of the problem. So read the case another time.